In this video, we are going to explore the topic of carboxylic acids, which are another important homologous series of organic compounds. Like alkanes and alcohols that we studied earlier, carboxylic acids follow a recognizable pattern in both their structure and their naming. The functional group that defines a carboxylic acid is written as COH, also read as carbon, double bonded to oxygen, and also bonded to a hydroxyl group. This group gives carboxylic acids their chemical properties and their characteristic reactions. In terms of naming, all carboxylic acids end with the suffix anoic acid. For example, the molecule that contains 3 carbon atoms and this functional group is called propanoic acid. For exam preparation, you need to remember the names and structures of the first 4 carboxylic acids in the series. These are methanoic acid, which has 1 carbon atom, ethanoic acid, with 2 carbon atoms, propanoic acid, with 3, and butanoic acid, with 4 carbon atoms. When writing their molecular formulas, it's essential to show the COH group as a whole and to place it at the end of the formula. This clearly represents the functional group and its position in the molecule. As their name suggests, these compounds are acids. However, they behave a bit differently from strong acids like hydrochloric acid or sulfuric acid. Carboxylic acids are considered weak acids, which means they do not fully ionize in water. In other words, not all of their molecules release hydrogen ions when dissolved in water. Because of this partial ionization, we represent their dissociation using a reversible reaction arrow. On the left side of the equation, we have the undissociated acid, and on the right, we show the carboxylate ion, which is the deprotonated version of the acid, along with a hydrogen ion. For example, propanoic acid will partially ionize to form a propanoate ion and a hydrogen ion. Notice how the name of the ion changes. Instead of ending in anoic acid, the ion ends in anoate. This pattern applies to all carboxylic acids. Ethanoic acid becomes ethanoate, methanoic acid becomes methanoate, and so on. Like all acids, carboxylic acids can react with metal carbonates to form a salt, water, and carbon dioxide. This is a typical acid-carbonate reaction. For example, if we react ethanoic acid with potassium carbonate, the products will be potassium ethanoate, which is the salt, water, and carbon dioxide. This reaction can be used as evidence of the acidic nature of carboxylic acids, even though they are weak acids. Finally, let's discuss how carboxylic acids are made. The process is straightforward. We take an alcohol and oxidize it using a chemical called an oxidizing agent. This means that an oxygen atom is added to the molecule. For example, butanol, which is an alcohol with 4 carbon atoms, can be oxidized to form butanoic acid, which also contains 4 carbon atoms and has the COH functional group. This transformation is a key concept in organic chemistry and links the alcohol and carboxylic acid homologous series together. In summary, carboxylic acids are organic compounds containing the COH functional group. They are weak acids that partially ionize in water, form carboxylate ions upon ionization, and react with carbonates to produce salts, water, and carbon dioxide. They are named using the suffix anoic acid and are commonly produced by oxidizing alcohols. Understanding these properties and reactions will help you recognize and work with this family of compounds effectively. That's all for this video. I hope you found it helpful. If you did, feel free to share it and stay tuned for more lessons. Thanks for watching.